I'll be going through current scenarios and what are the controls using AR and VR. For the part, we'll be going towards first, Pallavi has mentioned what is RigBetel Labs, right? Everyone might have heard what is RigBetel Lab, what we do exactly. So we do have our robots, we provide the services for the robots, but what after that? Just a second. Okay, so my name is Yatish Kumavat. I'll be going through using of AR, VR, current technologies for the use in 2D UI or user interface into the robotics control and visualization. So for the RigBetel Labs, you might have seen the video. Over here, you might see some videos over here, which are augmented reality and virtual reality controls. So we do provide services for that as well. So, graphical user interface. Some of you might have seen this screen, right? Anyone? Have you seen this screen? Most of you use this kind of UI to control the robot, right? Am I right? Yeah. So what we do, if we want to control a specific robot, we just open a terminal and check on the RVs what is the current scenario for the robot. And we try to control the robot through the terminal. But is it a good solution to use the terminal just to control a specific robot? Even we have tried RVs and we have stretched it thin to the point so that it will be able to load everything for us. So what you see over here is basically we created a submersible robot which is basically added a URDF into the RVs and created a material in the Blender so that we'll be able to load the whole model into the RVs and check the exact visualization of the IMU data and other data as well. Yeah. So now we have seen RVs, Gazebo. There are other solutions available in the market which are Foxglove and other solutions what you see over here. But are these things viable to use as a client? You are developer, everyone knows here what is ROS. So everyone knows how this thing works. As for the client we face, do they need the exact data or X, Y, Z axis? What is my position? What am I doing over here? Do they need that? They don't basically. They want to see the exact visualization for the robot, what it is doing and what kind of the action it will be covering. We had started with the web app for the robot control before starting ROS and everything. So you might be able to see over here. There will be a lot of videos in the presentation, so please stick with me. What you see over here is basically creating a web app. You might have seen the video on YouTube, tutorials and everything. This is most probably everyone might have started for the UI ROS. You might have seen the video, right? And then came the Unity. Some of you might have mentioned Unity before, right? I was listening. So what is Unity exactly? Why do we use Unity? It is basically a game engine, but it does have a lot of freedom in it so that we'll be able to create anything. It does have physics engine so that we'll be able to process exact physics required for the simulation of the robot. It is meant for the gaming engine and it tries to be realistic as possible. But for a robot simulation, we need exact same thing in that as well. After that, Unity has a lot of packages and support available for it. So it is basically starting will be very easy. And it supports a cross platform. So it is able to build on Android, iOS, Windows, Mac OS, Xbox or anything. Wherever you want that specific app to be, you'll be able to build it on the Unity. So what I'll be going through next is basically the UI apps at RigBetel Labs, what we create and what we are trying to achieve. So for the 2D UI apps, we try to be as specific as possible, because every robot has a specific one task to be completed. It can be multiple tasks, but it is meant to have a single task which it should be efficient at. So why do we need a lot of data for that? You just provide a specific data, what you will be going through, and just show that exact data to the robot and to the user client. So what you see over here is one of the project at RigBetel Labs for a DRDO client. So what you see is UAV drone over here. So it is moving around in the space with MAVROS. So MAVROS, most of you might have heard about MAVROS. It is for the drone. So it is getting a waypoints navigation from the GPS location, latitude and longitude, and it is able to move to that specific waypoint. What you see over here is basically a map created for the drone to be able to follow it. So you'll be able to see the camera image over here, getting the live feed out of it. You'll be able to see the exact data, what the user needs, rather than all the data provided by it. If you have heard about MAVROS, you know there are almost 200 topics available in the MAVROS just to be able to see the data. But do we need that? We don't basically. So what we do is we try to visualize that data with minimal user interface. Next is basically a 2D app. You might have seen on a booth, there was a waiter bot over there. So the waiter bot has a simple task for it to be assigned. It takes an object and goes to the second location, whatever you have assigned it for. So what you see here in the tablet is, it's a mobile Android app which is able to load the whole map, and it will create the whole map and save in its own database. So that when you give a position of the robot, it will be able to give that position directly to the robot and it will try to execute it. It is similar kind of robot over here. Social interactive robot. Basically, when we use robots, it has a specific task. I have already mentioned that. In this case, it is specifically to show you like a kiosk. So you are able to see the exact data, where you are, what you are trying to achieve, or where are you trying to go. So you can see in the first video, there's a basic information shown on the tablet. In the second video, you'll be able to see the basic navigation. As for the third video, you'll be able to see the exact precise object detection and object avoidance. So you'll be able to see this is India basically, so everyone knows. If you see a robot, you'll try to be in its path, right? Whoever has tried that, you know. So what it does is basically avoid that all the obstacles, and it will try to move exactly. If it has an object in front of it, it will just stop for a moment till you move aside. After that, what you see over here is basically a URSIM replica. So URSIM is basically a software given for the universal robots to be able to, if you want to use universal robot, it may be UR5, UR10, it can be anything. So if you connect to that specific robot, you'll be able to control that robot through URSIM. But some of our clients does not need those things. What they want is their own solutions. So we had replicated the exact same thing with MoveIt. So we had integrated ROS into the robotic arm, and we are trying to achieve the exact same with the UR5 over here. So you'll be able to see we are connecting with a specific name, IP and port. After that, most of you might have heard about digital twin, right? How many of you heard about digital twin? Okay, most of you have heard about digital twin, right? So digital twin is basically a technology where we create an exact one-to-one replica of the environment. But as for the environment, there are some components. If we want a machine to be integrated into digital twin, what we do is create that specific machine and get that data into the digital twin and give the exact data back to the machine so that it will be able to load the process. So what you see over here is basically a stepper motor which has 0.03 degree precision, and it is able to dynamically control the steps, angles and the degrees of the stepper motor. So this is the app for that. It is basically simple app which you will be able to control and give a specific command to. It does have an option to create a sequence as well. So when you add a sequence of specific angle or specific delay, after that you will be able to execute the whole thing. So everything over here was just 2D UI and UX. So what's next? How to make everything more realistic or more interactive for the humans robots communication or the control or the visualization. So let's hop on into the future. What you see over here is the augmented reality representation of the robotic AMR controller. So what you see in the first video is basically a Cepheus robot, which you will be able to see that at our booth, which is we are getting the exact data of the Cepheus. What is the speed? What kind of task it has been assigned to? What is the rotation angle and everything on top of your app. So what you need to do for the AR app is just open the AR app, scan the ARCore marker on top of the robot, and you will be able to get the exact coordinates and exact data from the Cepheus. As for the second video, I don't think it is playing. Can you check that, please? Yeah, thank you. So in the second video, you'll be able to see a AR nav, a product by RigBetel Labs. So what it does is basically you're just opening your mobile, pointing towards the ground on your mobile, and it will be able to detect the position on that ground, and it will send that position directly to the robot so that the robot will be able to calculate everything and get the global position with respect to its own origin and move towards that goal. So what you see over here is just pointing towards the specific location, and the robot will execute the plan and it will try to move towards the specific goal. So in this thing, we are using ARCore, which is made by Google. Most of you might have heard if you have heard about Unity. So over here, what you see is basically a robotic arm, move it based. So what we are doing is we have a robotic arm in our office. So what you see over here is a digital twin of that specific environment. I'll be showing the exact digital twin afterwards. So this is just for the robotic arm. What you see over here is the Eric arm, which we are controlling through the green gripper you see over there. So in the green gripper, you just pick that up with your controller and move it around. After moving it around, you'll just execute the plan and it will try to move to that specific location. So we have even played the Jenga with that. So what we had was two robotic arms and we were controlling through the VR rather than able to control with RVs or gazebo, something like that. We were controlling it through VR and playing the Jenga. Okay. Most of you might have heard about Ben 10. How many? Ben 10. Okay. For the people who does not know what is Ben 10, it is cartoon for kids basically. So I was watching that before like 10 years ago. So in that, a guy or a dude has a watch on his wrist and he rotates the dial of that watch to turn into a specific alien. So this project was just for fun to replicate that exact thing. But in this thing, we had a watch, we had our robots, and after rotating the dial on the watch, we are able to change the robots. And after changing the robots, when we hit the dial, it selects the specific robot and we can just point towards the ground and spawn that robot in the environment so that we'll be able to control it later on. Okay. Now what you see over here is the exact one-to-one scaled model of our office, the digital twin, where all the robots you see over here has been controlled through the ROS TCP endpoint, and exact position scale has been given to the digital twin as well as the real robots. So you'll be able to see there's a Tortoise bot, there's Tortoise bot Pro Max, and we are able to control those robots by giving a specific voice commands. So just giving it a goal to the specific location, the real robot moves alongside with the virtual one. So it gives us access for the robots to be able to control from anywhere in the world. So what you just need to do is just connect to your digital twin, you get the exact replica of the model, and you control the specific machine or robot. It can be a CNC machine, it can be AMR, it can be robotic arm, it can be anything. You just control from the digital twin and it will be able to reflect exact same thing in the real environment. So this is made just for the harsh environment we use the robots in. So it might be high temperature, pressure, those kind of things. So thank you for this.